Welcome in this session, Being the Master of Disaster by using Azure Site Recovery, delivered by the Azure Apes. My name is Peter Tander. I'm the founder of Azure Apes, Azure Platform Experts in Full, and you can reach me by email or connecting on Twitter. I'm a Microsoft Azure architect and trainer, an Azure MVP, and in my free time I keep myself busy by writing books for Pact Publishing Apress or creating courseware. In this session I have basically one main topic to cover. It's called Azure Site Recovery. Now, to make sure that you understand what Azure Site Recovery can help you with is starting from why disaster recovery is actually important to you as a partner or your customers. Moving over to what is disaster recovery and what solutions are available, and then spending the rest of my session dedicating to Azure Site Recovery, and in between doing some demos and tackling questions. Now, first of all, why disaster recovery is actually important. Now, most customers, when you talk to them about providing a disaster recovery solution, they always think about natural disaster, where depending on your specific geographical location, it might be more or less important. Think back about what happened a couple of weeks ago in the United States. Now, interesting enough, when you're actually drilling down on the root cause of disasters, it's actually not always, and even in less and less scenarios, actually pointing to natural disasters, which in short means a disaster recovery solution should be developed, should be made available for each and every organization, big or small, no matter where you are located in the world. Another interesting aspect is a discussion around backup and disaster recovery, where, interesting enough, backup is not exactly the same as having a disaster recovery solution. Backup is mainly pointing to restoring data. That's a true value proposition. If you change data, you modify data, you lose data, then you want a medium to restore from, and that's called backup. Where, pointing to Azure, a solution would be Azure Backup in any different flavor Azure is providing you. And a typical hero scenario is, oops, I deleted something, can you please restore my mailbox, or keeping it as long-term retention. Where disaster recovery, on the other side, is really about recovering an application, where you don't really need to restore data, or maybe you don't even have the time to restore the data. Where the solution would be Azure Site Recovery, and I'll talk about that Azure feature a lot more in detail in the rest of the session. Where the hero scenario, again, we're talking about becoming the master of disaster, is truly disaster recovery, or if you want, using it as a migration, and I'll talk about that later on. Now, when we look at familiar, I would say 20-year-old disaster recovery solutions, it could look something like this. In one data center, you deploy compute nodes, virtual machines, physical servers, where obviously virtualization was an interesting disaster recovery solution, making it a lot easier to really recover a failing or faulty virtual machine. Next to that, obviously, you need to provide data storage, where the typical DR solution in one single data center would be deploying two storage solution areas. Moving over to a more complex scenario, instead of having one data center, is deploying two data centers, where you're basically replicating, mirroring everything from data center 1 into data center 2, which means, for example, stretch clustering across a single VLAN, deploying, again, additional physical servers, additional virtual machines, and obviously replicating SAN storage solutions. Providing load balancing between data center 1 and 2 is made available through a scenario called geo load balancing. A couple of scenarios, components, storage replication. It's been there for the last 20-25 years. It's a valid solution. It still runs today, even within Azure if you want. So it's one of the options available. A stretch cluster using a single VLAN with a single address space is another typical configuration. Disaster recovery can be defined in an active-passive, or if you want even active-active setup, depending on complexity of the application, budget, and so on. Now, although all those scenarios are effective, most of them are actually pretty expensive to deploy, expensive to maintain. Another downside of using this kind of scenario is vendor lock-in, which, for example, means that if you're using a storage solution from vendor 1 in your data center and you want to provide high availability, you want to provide disaster recovery, then most scenarios you're going to stick to the same hardware vendor. Or even if you're migrating data, replicating data, providing a disaster recovery solution for your data between one data center and the other, best practice would be to still reuse the same storage solution from the same vendor. And overall, it's pretty difficult to perform partial failovers because it's all or nothing. But what if only one workload in your data center is failing? Does it mean that you have to fail over everything from data center 1 to data center 2? In a lot of scenarios, that's actually the case. Which obviously brings me to Azure Site Recovery as being one of the Azure built-in services providing you disaster recovery scenario solution. Now, in short, Azure Site Recovery gives you one single solution for multiple infrastructures. In short, there are 5 different topologies available. The first one is a replication between Hyper-V nodes from one Hyper-V infrastructure to another, where everything is running on-prem. Between a single data center, multiple data centers is not important here. The second scenario is using Azure Site Recovery to replicate data from one Hyper-V node to the other, where the replication is not managed through Hyper-V, but based on SAN storage replication. A third scenario, that's where it really becomes interesting, is replicating from an on-prem running Hyper-V in your own data center into Azure virtual machines. Scenario 4 and 5 is about similar, but we're stepping away from Hyper-V, hypervisor, talking about virtual machines running on VMWARE, or even running physical machines. And to stretch it a little bit more, can be Azure running virtual machines in Classic, or even AWS, or any other cloud if you want. Where we're replicating again, in scenario 4, first of all, replicating from VMware or physical servers into another VMware host on premises, or scenario 5, the more interesting one in my opinion, replicating virtual machines from VMware or physical servers, or again AWS into Azure virtual machines. So in short, 2 main scenarios: using Azure Site Recovery as a cloud orchestrator to replicate data between your on-prem running data centers where no data goes back and forth to the Azure public cloud, or scenario 3 and 5, where we're really using Azure data centers as the disaster recovery scenario. Or an even more interesting one, since we're really replicating the full workload, replicating the full virtual machine or physical machine state, Azure Site Recovery is the ideal migration tool from your on-prem non-Azure cloud into Azure data centers. And I'll talk about that later on. Now zooming in on what I like to describe as the hero scenario. So a typical 3-tier, 4-tier if you want application is based on an Active Directory domain controller for security, a SQL backend, an application frontend, or an application tier. Can be a single server, can be multiple servers, it's not that important. For each and every physical or virtual machine in the primary site, you configure ASR protection, which executes a full replication from the virtual machine into Azure storage, creating VHD, disk files, and configuring Azure virtual machine configuration settings. During a failover, which is always executed in a manual way, the on-prem virtual machine or physical server will shut down, replicating the final changes before shutting down, starting up the Azure virtual machine, and your disaster recovery scenario is complete. So it's really that easy, and I'll show you later on in a demo. Another scenario is actually even more interesting, where you can basically integrate Azure Site Recovery Replication in combination with already existing application replication features. So for example, if my SQL backend in my on-prem primary site is an already existing SQL cluster, then nothing blocks me from using SQL availability groups instead of using Azure Site Recovery, replicating my data into Azure by using SQL replication. Or another typical scenario for Active Directory domain controllers, if you build out site-to-site VPN, replicating or deploying an additional domain controller virtual machine in Azure, obviously Active Directory will replicate across all domain controllers, where you still have the case or the option to decide between Active Directory replication or using ASR for replicating your primary sites running Active Directory domain controller into an offline Azure virtual machine waiting as a standby disaster recovery solution. Now, quite important, I already talked about site-to-site VPN in this scenario. For ASR itself, the true replication engine, you don't need site-to-site VPN. Now, obviously, site-to-site VPN, or if you want ExpressRoute, of course, becomes interesting and in most cases even required when your workloads are actually running in Azure. Why? Because your end users obviously still need to be able to connect to the workload running applications. And depending on the workload, site-to-site VPN or ExpressRoute might be required there. So that's in short what ASR can help you with. So I'm going to use the next couple of minutes to really walk you through the ASR configuration. In the first scenario, starting from Hyper-V workloads, where Hyper-V can be a standalone Hyper-V host, or if you want a System Center virtual machine managed Hyper-V cloud. So in short, it's about 5-6 steps, although I stretched it out a little bit, including disaster recovery testing and documentation. So the first step, obviously, on the Azure side is configuring what's called the Azure Site Recovery Vault. The Azure Site Recovery Vault is your secured location within Azure in which you define your protection. Next to that, you download the ASR provider. It's like an agent that you install on your Hyper-V or Virtual Machine Manager infrastructure. On the Azure side, since you're creating virtual machines, you obviously need an Azure storage account, you need virtual networks, and next to that, you enable protection in step 6. It's starting to replicate the virtual machines or physical machines from your primary site into Azure virtual machines. And that's basically it. Step 7, 8, and 9 is really testing out your failover, where you're verifying if your disaster recovery solution is actually working without touching the production environment. And next, running through a planned or unplanned failover. And I'll talk about that a little bit more at the end of my presentation. What's the main difference between those two options? And obviously in the last step, updating your disaster recovery documentation, making sure that whenever disaster strikes, you really know what to do and how to execute the failover. But in short, it's really easy, and I'll walk you through the portal configuration later on. If, however, we're talking about non-Hyper-V workloads, so again, virtual machines running on VMWARE, running in AWS, physical machines, or even Azure Classic virtual machines, you have to select the non-Hyper-V option in Azure Site Recovery. All steps remain the same compared to the already previously explained Hyper-V steps. The main difference occurs in step 2 and 4, where instead of just installing the ASR provider, the agent, you need to install an additional Windows 2012 R2 or 2016 virtual machine or physical server if you want, in which you install what's called the ASR configuration server and processing server. So it's like an in-between host that's used for replicating the changes and also translating from for example, a VMDK file into a VHD file in the VMware scenario, of course. All the other steps basically remain the same. You configure Azure storage accounts, you define Azure VNets, enabling protection, waiting till the source machine is fully being replicated into an Azure virtual machine, and from there on you can execute a test failover and performing a production planned or unplanned failover. And again, it's really that easy. So let me check on time. I do have some time to first of all walk you through some details and then moving over to the portal and doing some live demos. So again, in step 1, you create a recovery vault. So from the Azure portal, you select the recovery options, creating Azure Site Recovery Vault, in which you define the source and target environments. You can use the portal or using command line PowerShell CLI, or even pre-configuring everything from an Azure Resource Mgr template. Once your ASR Vault has been configured, the next step is creating a Hyper-V site or obviously a non-Hyper-V site, where the Hyper-V site is basically a logical group really combining multiple Hyper-V servers together. Now, nothing really blocks you from deploying multiple ASR vaults within a single subscription or across multiple subscriptions. Now, quite important, a single Hyper-V server can only belong to a single Hyper-V site. That's really the logical boundary that exists. A couple of screenshots, but I'll show you later on in the portal how this is actually working. Once the Hyper-V site is being configured, you prepare the Hyper-V server, which is done by downloading and installing the registration key, downloading and installing the Azure Site Recovery Provider. You run the Site Recovery Provider installation from within the Hyper-V server or from within System Center Virtual Machine Manager. During the installation of the provider, it will ask you for your registration key, which is really your security mechanism and your integration into the specific Azure Vault that you created, where if you're running Hyper-V cluster, you need to install this agent, this provider, obviously on all nodes of the cluster. Where again, a screenshot installing the recovery agent. It integrates with a direct internet connection or allowing you to specify a proxy, where obviously, since all replication traffic will pass through the proxy, make sure that it's a pretty performing machine. And in the next step, it's really providing the Vault registration key, which is again your security and integration mechanism towards your Azure Site Recovery Vault. Moving on, this takes about 10-15 minutes to install to register all the servers. And once the server is recognized in Azure Site Recovery, you can move on and preparing your Azure resources, where again, in short, it's creating a storage account and an Azure Virtual Network. The storage account is being used for storing the VHD files, the Azure Virtual Network, obviously to provide networking integration for your virtual machines once they're running in a disaster recovery scenario, where the storage account and VNet configuration relies on typical Azure configuration settings, where you can define your Azure location. Using an Azure storage account gives you the option to define geo-redundant storage or moving down to local redundant storage. And on the virtual network, obviously you define the VNet, you define the subnets, you allocate your Azure location. With another screenshot, and again moving over to the next step, once your topology has been pre-configured, you can define your replication, really defining the protection. Interesting enough, think back about the old school typical scenario where in a lot of DR setups today, it's all or nothing. By using Azure Site Recovery, you can really define up to a granular level which virtual machines you want to allocate into the recovery scenario. So imagine you're running a Hyper-V host with 50 virtual machines, but only 5 of them are really critical to the business. Then you can configure protection replication for just those 5 virtual machines. Enabling replication allows you to obviously first of all select the specific virtual machines you want to protect, and next to that define the copy frequency, the recovery point settings, the frequency of the snapshots, and the initial replication start time, which by default is immediately, where a recommendation could be to define this after business hours to not saturate the internet connection during business hours. Once your protection settings have been configured, you can move over and really enabling protection. What this means is executing a replication from your on-prem or source environment, I should say. It's not always on-prem, could be another public cloud. And making sure that the virtual machine is being replicated to Azure. Once the machine has been fully replicated, it allows you to select the virtual machine size on the Azure side, which could be a smaller or a larger virtual machine size compared to the original machine configuration. Where obviously a virtual machine can only be a member of one single protection group, because that's really where the intelligence is being defined. In step 7, we're almost there. You can go through a test deployment. A test failover without Azure networking. This one could be used for just verifying that the virtual machine starts up, but it won't be connected to any Azure network. Or the more interesting one, testing failover, including Azure networking, which will allow you to really start up a copy of your already replicated virtual machine. So again, it's not touching production, making sure the virtual machine can connect to Azure networking, making sure that the services start up, and so on. You can verify the test failover process from the Jobs tab within Azure Site Recovery, and I'll show you in a minute. During the test deployment, a couple of things are actually happening. A prerequisite check for the failover, creating the test environment, creating a copy of the virtual machine, preparing the virtual machine, starting the virtual machine, completing the testing, cleaning up the testing environment, and finalizing test failover, which is pretty interesting, pretty granular, but in short, it should take nothing more than, let's say on average, 15 minutes. And my recommendation is really running this in a production ASR environment. So detailed view, and I'll show you in my upcoming demo. So first of all, from my Azure portal, I select my recovery vault. Within my recovery vault, I define my recovery vault settings, where, as I showed you or explained you before, it's really a walkthrough 4 or 5 step scenario. In the first step, you prepare your infrastructure, where you define where your machines are located. They're located on-prem. I want to replicate to Azure, or again on-prem in the other scenario, and defining if you're using Hyper-V, VMWARE, or not virtualized, which again could be AWS physical servers or any other public cloud environment. In the next step, again, you define your source environment, where, as I explained you, in a Hyper-V scenario, you define a Hyper-V site, and installing the Hyper-V ASR provider on the Hyper-V hosts, multiple or single server. And in the last step, you define your recovery plan. Now, obviously, to speed up the demo, I already pre-configured most of the settings here. So what I have is my source environment, and I have one virtual machine that's part of my recovery plan. Customizing a recovery plan gives you detailed granular options to really define how the disaster recovery scenario actually needs to happen. So obviously it executes an all group shutdown, which means that all VMs that are part of this group will be shut down first. Then it's executing the failover, where, interesting enough, it's giving me the option to really define the order in which virtual machines are executing the failover, where in this scenario I'm running a web server that's relying on Active Directory, where obviously I want to make sure that my Active Directory domain controller comes up first before performing the failover of my web server. For each and every of those specific steps, I can add additional PowerShell scripts, for example, to make sure that whenever something happens on my virtual machine, before executing the failover to the next one, you need to execute a couple of PowerShell scripts or any other scripts if you want. So it's a really intelligent, granular configuration of your failover scenario. Next to that, I can execute a test failover. Already ran this for this machine, so let me move on to the next step. Is really showing the configuration on my end. Since I'm talking about Hyper-V sites, in my scenario, it's one single Hyper-V site in which I have one Hyper-V host that's running in my on-prem network, and from the 15 virtual machines, I only selected 2 of them to be protected. Which brings me to the replicated items, where you can see the 2 machines are in a healthy state, which means they're fully replicated. The first one, my domain controller, is in a protected state, and my active location is my on-prem site, where the second one, the web server, I already executed a failover. So let me initiate a failover for my domain controller. Again, just to show you how intelligent, but also how easy it actually is. Now, before moving to the actual failover, let me jump to some additional machine settings. So the first step in replicating the virtual machine, Azure Site Recovery will try to map my source environment with an Azure-alike virtual machine. Now, interesting here, nothing really blocks me from changing the virtual machine sizes. So in this scenario, it's recognizing 1 core and a close to 2 gigs of RAM and 1 NIC, but nothing blocks me from moving to a larger or obviously a smaller virtual machine size. So imagine you have a pretty powerful database server running on premises, 128 gigs of RAM and 32 cores. But in case of a true disaster recovery scenario, maybe you don't need the full performance of the SQL Server, which allows you to select a smaller virtual machine size, which obviously also means that it's less costly when running in Azure. It also supports availability sets, which provides you high availability of the running virtual machine in Azure, and defining standard or premium disks as well. If you have multiple network segments in Azure, in your on-prem environment, like a production network, a backup VLAN, and a monitoring VLAN, then you can also define which of those networks should map to the Azure mapped virtual networks. So pretty granular options there. So for now, in the last few minutes of my session, let me execute a planned failover. It won't be possible to show you the full failover since it's taking about 15 minutes. But what I'm going to show you is the detailed level of logging here, where, as you can see, it's executing a couple of different steps, prerequisite steps, shutting down the virtual machine, preparing the failover, starting the failover, and starting up the replica as an Azure virtual machine. So I just keep this running for now, although what I do have is the same for my IIS machine, that I executed a failover prior to starting this session, and as you can see here, I'm running my IIS 2008 virtual machine, which is running, it's here running in Azure. I could RDP into my machine, verifying the IP settings and so on based on virtual machine failover, and showing you the detailed logging from that specific step from within my vault. I have detailed job monitoring reports. I can configure alerts. So this one is site recovery, where you can see the historical information of everything that happened within this specific vault. So this one was a planned failover from my IIS machine, where it's showing you the detailed information pointing to the networks, subnets, and so on, and really defining the prerequisite steps, shutting down the VM, preparing the failover, executing, and starting. Where if you take a look at the timestamps, it takes about 5 minutes to really fail over from my on-prem running web server into an Azure running web server, where the web server data is fully consistent with my on-prem running virtual machine. The last thing I promised you is a difference between planned and unplanned failover. The main difference, in short, is a planned failover performs a full shutdown of my on-prem running machine, replicating everything, making sure that all the data is consistent, where an unplanned failover doesn't really check the on-prem state of my machine. It's starting up from the last successful replication, which means depending on the application, depending on the workload, it might incur some data loss. But again, it's an unplanned failover, so a true disaster recovery where all of a sudden your on-prem environment is not available anymore. Like the virtual machine is down, the physical rack is down, or maybe even your data center is completely unavailable. And then in, let's say, 5 to maybe 10, 15 minutes, depending on the specific workload, you have your last successful replicated state of the virtual machine running in Azure. So with that, we're close to the end of the session, giving me some last words around protection plans, where a protection plan is, again, a grouped set of virtual machines, allowing you to really define actions during the actual failover based on customized PowerShell scripts. Typical scenarios here would be performing a DNS update, performing file copies between servers, or even updating network security group settings and allowing RDP traffic communication into your failed over virtual machines. Scripts can be created from the protection plan gallery or using your own custom built PowerShell scripts, obviously. I walked you through the demo and already explained the protection plan. So with that, one last word to share. Azure Site Recovery is part of the Operations Management Suite licensing subscription umbrella in Azure, where besides backup and site recovery, OMS also provides you detailed log analytics, automation, and security and compliance. I'm a true fan of Azure Site Recovery in that way that I even wrote a book about it. So if you're watching this session, follow me on Twitter, reach out, send me a tweet including my tweet handle, OMS, and obviously MVPDays. And out of the lucky ones, you might be the one and only winning an ebook copy of my Implementing Operations Management Suite book published by Apress. So with that, I would like to thank you for watching this session in which I talked about disaster recovery, what solutions are available, and providing you an in-depth view on Azure Site Recovery in between jumping into some demos. This was the Being the Master of Disaster session using Azure Site Recovery, delivered by the Azure Apes. I wish you a nice day, and I hope you enjoyed the rest of the MVP Day conference.